Let's have a look at index law number 2. Okay, so if index law number 1 was about multiplying two terms with the same base, you add the indices. Index law number 2 will be the opposite, will be the other way around. In fact, when dividing algebraic terms with the same base, we subtract the indices. Okay, so there's a bit of a connection there, isn't there? Multiplying algebraic terms, add the indices. Dividing algebraic terms, subtract the indices. Okay. So for example, if we had 7 to the power of 9 divided by 7 to the power of 5, that equals 7 to the power of 4, because 9 minus 5 is equal to 4. So the question is, why is this though? Why does this work? Let's have a look. 7 to the power of 9 is 7 times 7 times 7 times 7. You can see where this is going. We've got enough of them. 1, 2, 3, 4, 5, 6, 7, 8. One more. And that's over. Okay. So I'm representing the division as a fraction. 7 to the power of 5. 1, 2, 3, 4, 5. Now we can cross things off, top and bottom. That crosses off with that. This one crosses off with that one. Okay, and so on. That one crosses with that. What have we got left? How many 7s have we got left? 1, 2, 3, 4. So that's equal to 7 to the power of 4. Let's have a look at some examples. Okay, and these are fairly simple examples. There are obviously harder ones that we can look at, but this is just more about practicing this particular index law, just making sure that we understand the basics. All right, let's have a look at the first one. 3 to the power of 9 divided by 3 to the power of 3. Should be a division there. Yep. Divided by 3 to the power of 3. What do you think this one's going to be? As long as the bases are the same, always check that. The bases must be the same. Okay. 9 minus 3 is equal to 3 to the power of 6. Okay. You could put this in your calculator, but the question says just leave your answer in index form. Part B, x to the power of 10 divided by x to the power of 2. So it's like saying x times x times x times x times x. There's 10 of them over x squared. How many x's have you got left? Okay, so that's equal to x to the power of 10 minus 2, which is equal to x to the power of 8. Okay, what about part C? A to the power of 6 over a to the power of 5. It's a division. Okay, even though it's in fraction form, it's still a division, so we subtract the indices. Okay, so that's a to the power of 6 minus 5, which is a to the power of 1. Now, a to the power of 1, we don't have to show the 1. Okay, it's just assumed or implied that it's there. It's just equal to a. Okay, part D, y to the power of 10 divided by y. Now, a pronumeral by itself, or even a number by itself, it's always assumed that the index is a 1. And we subtract the 2. So that's equal to y to the power of 10 minus 1, which is equal to y to the power of 9. Okay, let's have a look at these bottom three examples, so E, F, and G. First one, 24b to the 14 divided by 6b to the power of 8. First thing we do is we divide the numbers. Okay, so this one's an easy one to do. 24 divided by 6, okay, that's equal to, okay, so in fact, I'll write it this way first so you can see what I'm doing. So 24 divided by 6, I'm writing it as a fraction, okay, and we're going to multiply that by b to the 14 over b to the 8. Okay, so I'm separating out the numbers from the pronumerals, okay, and then joining them together with a multiplication. Okay, after all, 24 and b14 are being multiplied together. The 6 and the b to the 8 are being multiplied together and down the bottom here in the denominators. Okay. 24 over 6, that's equal to 4. B to the 14 over b to the 8, subtract the indices, and we're going to get b to the power of 6. Part F. Now, same thing. This expression's already in fraction form. So 28 divided by -7. In fact, just to make it a little bit easier for you, let's separate them again. Okay, you don't have to do this, but I guess it just makes it a bit easier to see. All right, so 28 over negative 7 multiplied by c to the 15 over, that should be a c, sorry about that. Didn't see that before, so that should be a c. Yep. C to the power of 4. Okay. 28 over negative 7. All right, so a positive divided by a negative, that's a negative, negative 4. C to the power of 15 divided by c to the 4. Okay, it's a division, bases are the same, so we just subtract the indices. 15 minus 4 is 11. Okay. Now, last one, G. You've got negative 4x cubed y to the 4 over negative 10 xy. I'm going to separate these out. So negative 4 over negative 10 multiplied by x cubed y to the 4 over xy. Okay. So that's equal to negative 4 over negative 10. I'm going to separate these pronumerals as well. So I've done this in 2 steps. I could have done this all in 1 step, but I'm going to separate the x's and I'm going to separate out the y's as well. So that way I'm combining, basically I'm treating the terms that are alike, I'm treating them together, the same pronumerals or the same letter. Now, negative 4 over negative 10, okay, negative divided by a negative, you get a positive, okay. 4 over 10, you can put that in your calculator if you like, divide top and bottom by 2, you're going to get 2 over 5, multiplied by, now x to the 3 over x is x squared, and y to the 4 over y is y cubed, okay, 4 minus 1. Remember, when it's a pronumeral by itself, right, it has an index of 1. 3 minus 1 is 2, 4 minus 1 is 3. Now we can combine the answer together, okay, so the 2x squared y cubed is a numerator, 2x squared y cubed over 5. We can just squeeze that in there, so okay, over 5. So 2x x squared y cubed over 5.